Module 2, Definition and Meaning of Stack. Stack is non-primitive linear data structure into which new items may be inserted and from which the items may be deleted. In this data structure, the insertion and deletion of elements are carried out at one end, which is called as top. In stack, the element last inserted will be first to be deleted. Hence, the stack is known as last in first out structure. For example, we'll see consider the task of keeping books on a table, one above the other. When a person wants to take the book, he has to take the book which was kept last. Thus, the first book kept on the table will be the last book to be taken out. In the study of data structure, insertion of new item into the stack is called as push operation, whereas deletion of an item at the top of the stack is called as pop operation. When the stack is full, we can't insert any more items. The situation is called as stack overflow. Similarly, the stack is empty. We can't delete item from it. The condition is called a stack underflow. We will be having an integer variable top, which will be denoting the current status of the stack. That is, the value of top gives the number of items which has been present on the stack. Mostly for the programming purpose, an empty stack is denoted by setting the value of the top as -1. And each time when we will be performing push operation, the top will be incremented. When we have the pop operation which will be done, the top will be decremented. And the size of the stack in the programming purpose, we will be defining it at the beginning. For example, if you have 5 elements to be inserted, we will be saying it as stack of 5 elements. If we have 10 elements, then we will be writing it as stack of 10 elements. When the value of top becomes -1 during deletion, it is called as stack underflow. When the top reaches the predefined size, it is called as overflow. Let us see the figure to understand it better with respect to the stack operation. So let us see the first diagram. You can see the stack is empty. So we will be defining top as top is equal to -1. When we are inserting the first item, top will become 0. When we are inserting the second item, top will increment to 1. When we are inserting the third item, top will become 2. Now, in this example, the size of the stack is 3. Now, let us see in the deletion operation. So, when we are deleting the item, 37 is the last item which was inserted. So, that will be deleted first. So, top will be decremented. 41, when it is deleted, the top will be decremented to 0. 25, when it is deleted, top will become -1. So it will give the message that the stack is empty. There is no more items to be deleted. Let us see the second diagram, which will give a clear picture on push and pop operation. So let us see the stack is empty. We are going to insert first item. The value of the item is 2. So the top will be pointing to this particular item. Then we have the second item that will be inserted on the top of 2. Top will be pointing to the second item. We have 7 which will be inserted on the top of 5. Top will be inserted to this top will be pointing it to the third item, and then we have 1 which will be inserted over 7 and top will be pointing to 1. Now next let us see with respect to pop. So in the pop we can see in the above diagram 1 was the last item. So we have an operation pop. So top will be decremented and it will be pointing to 7 and 1 will be popped out. Next we have push operation. Push, we have the value of the item as 21. So the 21 will be inserted on top of 7 and top will be pointing to 21. Then we have pop. The last item with respect to the previous diagram was 21. So 21 value of the item will be deleted and then top will be pointing to 7. Next we have pop. So pop in the sense the last item that we can see with respect to the previous diagram is 7. So that will be popped out. Next we have pop. So the with respect to the previous we have 5. So that will be deleted and top will be pointing to 2. So there are some primitive operations that we have to understand when we take stack as an EDT. So here we will be having 6 operations. So let us look into it. The first operation we have is create stack. Create a stack of elements. Next we have push. Push an element on top of the stack if the stack is full, or else push operation is not possible. Pop. Pop an element from the stack, that is top element, if the stack is empty. Then pop operation is not possible. Then we have is empty operation, returns true if the stack is empty. Display, displaying all elements in the stack. Sixth we have is count. Count the number of elements in the stack. Let us see the algorithms and the steps and code. First algorithm is based on the push operation, where it is having 4 arguments which is specified as s, top, max stack, item. So we will be pushing an element on the top of the stack, and in case if the stack is full, the push operation is not possible. So step 1 is it will be checking if the stack is full. If the stack is full, it will produce an error. Step 2, if the stack is not full, it will be incrementing to top and pointing to the next empty space. Step 3, it will be adding the element to the stack location where the top is pointing. Step 4, if you are able to successfully insert the item to the stack, then it will return success. This is the code that we will be writing as per the step. We have to check overflow. So we will be checking this condition, top is equal to mass stack minus 1. Then we have to print, if this condition is there, then we have to print it as stack overflow or else return. Step 2 is in case if we have much space to insert the element, then we will be incrementing the top value, which we will be writing the code as top is equal to top plus 1, and then we are going to insert the item at the top, which will be specified as a kind of an array, which will be written as a code as s of top is equal to item. Step 4 is return. Next we have algorithm is for the pop, where we will be having 3 arguments as top, item. Pop an element from the stack, that is the top element. If the stack is empty, then pop operation is not possible. It is also having 4 steps. Step 1 is it is going to check if the stack is empty. If the stack is empty, it is definitely going to give an error. Step 2, if the stack is not empty, then what we have to do is the data element at which top is pointing. We have to access the data element at which top is pointing. Step 3 is we have to decrement the value of top by 1. And if this is deletion is done successfully, then step 4 it will return success. This is the coding that we are going to write. Step 1, we have to check underflow. So for that we are going to check this condition. If the top is equal to -1, if the top is equal to -1, then it has to print a stack underflow. Then in case if there are items to be deleted, then we have to delete the item. So we have to specify where the item is there. So we are going to write the code as item is equal to s of top. Step 3 is we have to decrement the top value. Top is equal to top minus 1. When all this operation is done, step 4 is exit. Next algorithm that we have is display, displaying all the elements in the stack. Display function we have, and we have a variable I. We have to check a if condition, that is top is equal to -1. So if this condition is satisfied, or if it is that is top value will be compared to -1, and if it is satisfied, then we will be printing it the stack is empty. No more items cannot be deleted. If it is not satisfied, then the else part of the code will be executed. That is, the first statement is the stack contains from top to bottom, that will be printed, and then the for loop will be executed. So in case if it is having 5 elements, one by one the item will be displayed. So we will be writing it as for I is equal to top, I is greater than equal to 0, and decrement the I variable. To print the element, we will be using print, that is the I element, as it is integer, we will be using %t, and to go to the next item, we will be writing it as I plus 1 s of I. Next function we have is empty. It will be returning true if the stack is empty. And this is the code for is empty. Here the return value is integer, so this condition will be checked. That is the coding is written in the way to check if the stack is empty or the stack is not empty. So if the stack is empty, this condition will be checked. If stack is not empty, this condition will be checked. So if the stack is empty, it will return true. If the stack is not empty, it will return false. Stack top. Next thing that we have is the stack top. Stack top is similar to is empty. So the same thing it will be written. Okay, the condition is same as is empty, but if this condition is met, it will be printing stack underflow. Else, the particular item that has to be popped out, that has to be deleted. Let us see a program which will be implementing stack using an array. So we have a library function, we have a macro which is fixing the size of the stack, and then we have a top variable which is initialized as -1. So that means that initially the stack is empty. Okay, and then we have an array that is defined as integer, and the name is s of mass stack. And in the main function we have a variable choice, and to execute the that is we will be having to list the list of operations. We're going to use while loop, and in while loop we will be printing push operation, pop operation, display, quit, and then we have to enter the choice, and based on the choice the code is written inside the switch statement, where we have the various cases. Based on the choice, the particular case will be executed. Okay, so based on the choice, for example, if we are entering the choice as 1, then this case 1 is having push operation, where the push operation will be defined here. Okay, so here we will be having a item which is an integer variable, and then the top will be checked for mass stack -1. So if the mass stack is, if the top value is matching with mass stack -1, then we will be printing it as stack overflow. Else we say that we can, if there is more items that is being present in the stack space, then what we have to do is we have to enter the item value that has to be pushed. So we will be entering the item, and we will be using printf and scanf. And then, as we have already seen in the push operation, we have to increment the top. So we will be incrementing the top and placing the value at the space of the stack, which we are going to mention it in the code as s of top is equal to item. Then we are going to see pop. So pop in the sense, if we are going to check this condition, if top is equal to -1, then we have to print it as stack underflow. Else, the what if the item is present, then we have to pop up the item, so one by one, and after that the top will be decremented. And in case if we have to display all the elements, and then we will be using the display function. For that we will be checking first if there is any items are present or not. So we will be checking this condition, top is equal to -1. So if this condition is satisfied, that means that the stack is empty. If this condition is not satisfied, then we will be executing the else part, and we will be displaying the list of items which has been present with respect to the for loop and the print statement. So this is how the output will look. This is how the various operations will look like. This is an example for push, and this is an example for pop. Now let us consider the following stack of characters. We'll see another example where we will get to explore more of the pop and the push operation, where we will be having 8 values, and the 8 values of the stack is represented as A, C, D, F, K. And the first is a pop stack item. So you can see with respect to this, A is the first item and K is the last item. So when we do this particular operation, as per the last item is K, that will be popped. Again, in the second, we have pop stack item. So the second last is F, so that will be popped. Now third, we have pop stack item, that is D, so that will be popped. Next we have is push stack R, so that means that to this particular stack R has to be inserted. So we have popped it till D. Okay, so after AC R will be inserted. So that means that R is the last item. Next is what push to stack L. So on the top of R, L will be inserted. Next is what push to stack S. On top of L, S will be inserted. Next is what push to stack P. On top of S, P will be inserted. Next is what pop. So with respect to the previous output, we could see that the list of items that we have inside the stack is A, C, R, L, S, P. So with respect to the last operation, the last item is P, that will be popped out. We'll meet in the next session.